Hey guys, today I'll be kickstarting the series of proving famous limits and derivatives. This is the part 1 of the limits and derivatives. First, I will prove these three limits. Limit as x tends to 0 of natural log of 1 plus x raised to x, by x is equal to 1. Second will be limit as x tends to 0 of e to the x minus 1 over x is equal to 1, and 3 is limit as x tends to 0 of a to the x minus 1 over x is ln a is a constant. You might be wondering, what is e? Well, e is approximately 2.718, or we can define e as limit as x tends to 0 of 1 plus x raised to 1 over x. This is one way. Or you can define it as limit as x tends to infinity of 1 plus 1 over x raised to x. We'll be mainly using this definition of limit to prove all this. So first I'll prove this one. Okay guys, I'll prove this limit first. What we can do this. So this is equal to limit as x tends to 0 1 over x times ln 1 plus x. Well, it's just standard, and we are going to use the laws of logarithm to put this over here. So it will be limit as x tends to 0 of ln 1 plus x raised to 1 over x. Well, here I am going to use an important property. Limit of x tends to, let's say, a of ln f of, so limit as x tends to a of ln of f of x is equal to the log of limit. So limit of a function is, limit of log is log of limit basically. So we can put this ln outside. X tends to 0 of 1 plus x raised to 1 over x. Well, what was this in the first place? Yes, this was e. Therefore it will be ln of e, which is 1. The first limit is proved. Okay, now I'm going to prove this limit. First I'll make a substitution of e to the x minus 1, that is equal to h. So e to the x is equal to h plus 1, and if we take the natural log of both sides, it will be x equal to ln 1 plus h. So as x tends to 0, h tends to 0, right? Yep. So it will be limit as h tends to 0 of h over ln 1 plus h. Okay, this looks like an awful lot similar like this, but it's just a reciprocal. So what we can do is take reciprocal of this. Reciprocal of the limit will be limit as h tends to 0 of ln 1 plus h over h. What this was 1. If this is 1, then the reciprocal is also 1. Therefore limit as x tends to 0 of e to the x minus 1 over x is 1. Proved. Okay, so the third limit is limit as x tends to 0 of e to the x minus 1 over x is equal to ln a, where a is a constant. Okay, So I'm going to make a substitution. Not substitution, is like e to the ln a to the x, or equal to e to the x ln a. Yeah, limit as x tends to 0 of e to the x ln a minus 1 over x. Okay, this looks very similar to e to the x minus 1 over x, but here x is equal to x ln a, and there is no ln a over here. To do this, we will multiply by ln a, and to compensate we will divide by ln a. So it will be, okay, so this will go up, so it will be limit as x tends to 0 of ln a e to the x ln a minus 1 over x ln a. Since x is not in this term, we can just take it out. Limit as x tends to 0 of e to the x ln a minus 1 over x ln a. Notice this and this are equal, and if this and this are equal, this is the same as this. And what was this we proved? This was 1, so it will be ln a times 1 equal to ln a. And this is the proof of the three limits. These three limits will be used to prove the derivatives of ln a, e to the x, and a to the x, which will be in the next video. Bye bye.